So welcome everybody. So thanks to all be there for these 3 days of training workshop, focusing on solutions to tackle WFD requirements for estrogen determination in water. So just to remind, this training workshop aims to present the knowledge gained from the EDC-WFD project, whose objective is to develop reliable and harmonized measurements method for estrogens, which are key endocrine disrupting chemicals, to comply with Water Framework Directive requirements. And its aim also especially to accelerate the transfer of the most promising measurements method and methodologies to interested parties, laboratories, proficiency test providers, and of course, researchers. This training workshop will cover all aspects of measurements from sampling to final method validation and address both mass spectrometry-based method as well as incoming effect-based method. And this last point will be our strong focus for this third session. Since Wednesday, we have overpassed all the sample prep issue and all the big important point and important knowledge we have gained within our project, from the sampling time to the final sample prep time. And yesterday, we focused on mass spectrometry-based method and all the achievement we have observed and achieved during the project. And we have shared with you all our performance of the method performance we achieved at the end of the project. And now it is time to focus on effect-based method. And I would like to know if all the attendees of today's meeting participate to the Wednesday meeting. If yes, it means that you have yet all known what we are doing, who we are, and what was the initial purpose of our project and the general context. If not, I will make this presentation a second time for those of you who were not there. So please, could you just by perhaps raising your hand, inform if you were not there on Wednesday or yesterday about the project context. Karine, please, could you tell me if there's some raised hand?
I think nothing.
Okay, so if you were all there, I think that we can directly go on the strength of strength of this EBM session, and I will let the floor to my colleague Monica Potalivo just for to introduce you about EBM methods.
Good morning, everybody. I'm sharing my my screen. Do you see the screen, and is it the presentation in full mode?
Yes, thank you.
Thanks. So good morning again. I'm Monica Potalivo, and with this presentation, I would like to give you an overview on effect-based methods, in acronym EBMs, in terms of state-of-the-art and their potentialities. The EBMs are mentioned in several common implementation strategy guidance documents, and moreover in two technical reports. The report on the left-hand side has been published in 2014, whereas the report that is on the right-hand side is the most recent one. It has been published in 2021. And some information of my presentation of today are taken from these two technical reports. The effect-based methods in a Water Framework Directive context have several main uses. They can be used as screening tools, as part of the pressure and impact assessment, They can also be used to consider the effects from mixtures of pollutants not routinely analyzed. And last but not least, they can be used to provide additional support in water and sediment quality assessment. They can be categorized into 3 main groups depending on the type of the selected monitoring approach. We have in vitro and in vivo bioassay, we have biomarkers, and we have the ecological indicators. With regards to the estrogens and to this presentation, I will mainly focus in the next slides my attention on bioassay, in vitro and in vivo bioassay, which measures the toxicity of samples on cellular and individuals level respectively. The most recent technical report also provides the effect-based methods inventory list, which was also one of the deliverables of the subgroup ABM within the working chemical group. And according to this inventory, there are more than 100 assays. On the right-hand side, also, you can see all the possible effect-based methods, mode of action. As you can imagine, and as you can see from the slide, there are quite many mode of action. With regards to estrogens and the projects, again, we are dealing with in vitro reported gene assays, which have been used to determine the total estrogen receptor mediated estrogenicity of an environmental sample. The resulting overall estrogenic activity of a sample is reported as biological equivalent concentration in acronym BEQ. Again, with regards to the estrogenic activity, which implies the activation of the estrogen receptor as mode of action, the technical report lists the available ABMs. As you can see, there are just a few ABMs which have been standardized at ISO level, and there are other 2 effect-based methods. Actually, there are the OECD guidelines also provide standardized procedure for Eracalux and another bioassay. The validity of the others with respect to ISO level should be yet demonstrated. Unfortunately, the mentioned standardized SOP are developed for real water sample without providing clear indication on the sample preparation to be applied, and moreover, none of them have been validated in accordance with QA/QC directive requirements. As added value within the project, we aim to apply and validate the whole procedure, selective sample prep plus bioassay, to investigate the potentiality of the procedure and, moreover, to assess the possibility to detect the estrogen content versus the overall estrogenic activity. Moreover, the whole procedure will be validated in accordance to QA/QC directive requirements. The estrogenic potential of a sample is normally expressed as EEQ, meaning beta-estradiol equivalent concentration. A guideline to calculate the BEQ, in this case EEQ, from experimental data has recently been published. I'm referring to the ISO 23196, which has been published last February, in February 2022. The EEQ concentration corresponds to the estradiol concentration, which causes the same effect as the combined activity of all compounds. When I'm talking about combined activity, I'm referring to all the compounds, both agonists and antagonists, which may be present in the sample. 2 main models for joint actions of mixtures are also reported in literature. I'm referring to the concentration addition model and the independent action model. Since all the estrogens have the same mode of action, from now on, I will refer simply to the concentration addition model. And the concept of the concentration addition model is based on the idea of a similar action of mixture components. It's quite easy to understand that among the estrogens, we cannot have the same responses. It's quite common to detect, to observe different responses. Just think about the differences between the responses given by ethinyl estradiol and nonylphenol or bisphenol A. Moreover, it's quite common to observe non-similar behavior between the chosen reference compound, mixture, or the sample. To minimize eventually data interpretation issue, because these two bullet points can lead to data interpretation issue, is crucial, and it's very important to determine relative potencies associated to the contaminants which may be present in the sample. Relative potencies are specific to each estrogen and bioassay. They are very important because they can be used to bridge chemical analysis to bioassay, and moreover, by means of relative potencies, also some mass balances evaluation can be assessed by means of the equation that is reported in this slide in red. Of course, to apply this equation, we have to make an assumption that we have to assume that we have similar behavior for those response curves between the reference compound and the target compounds, or among the target compounds. When I'm talking about when we are mentioning the EEQ chem, we simply mean the let's say the estrogenic activity determined by chemical analysis, transforming the individual content determined by chemical analysis by means of the relative potencies. We are summing all the single contribution by means of the individual relative potency, which is given as the ratio of the effective concentration at X level of the reference compound, and against the effective concentration at X level of the target compound. Here, just a very simple flow to summarize the main differences between the ABM procedures and MS-based methods procedures. First of all, it's important to clarify, to make clear that the internal standards addition is not permitted in ABM's analysis, because according to their definition, they won't be able to discriminate the contribution due to the internal standard to the one that is associated to the targeted compounds. Whereas in MS-based methods, as we have already seen during our previous sections of yesterday and 2 days before, the internal addition is a key point in MS analysis. Afterwards, we may apply the same sample extraction and cleanup procedure to our samples. But we have to keep in mind that once the sample prep is concluded, the final extract needs to be evaporated, and a suitable solvent needs to be added to the dried final extract. And the two suitable solvents may be different, because it's quite common that suitable solvents for bioassay are not suitable as well for MS analysis. And of course, when we have changed the solvent, we can either apply bioassay analysis or instrumental analysis. Here I want to summarize the main differences between ABMs and MS methods. To just remind, the ABMs detect the overall estrogenic activity in samples, whereas MS-based methods determine the single target compound's concentration. And for this reason, MS-based methods, of course, are aligned with Water Framework Directive chemical status evaluation of surface waters. But unfortunately, they cannot detect the interaction of target compounds, which can give toxicological effects different from the ones that can be expected. Moreover, MS-based methods cannot detect toxic effects that can be due to unknown contaminants, which are not addressed by the Water Framework Directive. The internal standard is not permitted, whereas it's a key point for MS-based method analysis, because by means of the internal standard addition, a more robust identification of contaminants is possible. Moreover, both absolute and relative recoveries can be achieved. Whereas, since we are not adding internal standards in ABMs, this robust identification is not possible, and we can assess only absolute recoveries. If we combine an appropriate sample preparation to ABMs, we can achieve promising low LAOQ. Whereas, even if we apply an appropriate sample prep, it might be possible that for MS-based methods, low LAOQ, the achievement of low LAOQ could be still a challenge, because of course it depends on the status of the instrument. For this reason, indeed, ABMs can be considered as a valuable pre-screening tool to support chemical analysis in chemical status evaluation under the Water Framework Directive. Generally, good agreement between EEQ Bio and nominal EEQ Chem is observed. This is due to the fact that just a few potent estrogens determine the overall estrogenic activity. For this reason, in case significant discrepancies in mass balances are observed, it means that the model criteria are not fulfilled. And if the model criteria is not fulfilled, means that we might have present in our sample in the interaction between components or the presence of unknowns that could have a significant impact on the model. And in this context of the Water Framework Directive, again, the effect-based methods can be used as link between chemical and ecological assessments. Within the project, 2 wall procedures will be fully validated. These wall procedures will imply a sample preparation plus either the IS or the R-alpha calyx. We have selected IS and the R-alpha calyx because they are both standardized effect-based methods, and also because they are easily available in the market. Regarding the selected sample prep, we will apply an extraction carried out by means of speed disk, plus a cleanup procedure which will take into consideration MIP SPE cartridges. The validation is still ongoing, and at the end of the validation process, the results will be compared. And that's the reason for which, unfortunately, I cannot present at the moment and in this presentation any results, but we are working on that point. Do you have any questions, concerns, comments on this first presentation, on this overview of EBMs?
Have you got any question?
Nee.
Ist das die Französin?
Ich weiß nicht, wo die herkommt. Nee, das ist nicht die.
Das ist eine andere.
Das ist jetzt eine andere, die vorträgt.
I saw Sebastian, who want to talk.
Yeah, thank you very much. Good morning, and thank you very much for your presentation. I think I asked this question already on Wednesday, I just wanted to raise this issue again, and because it's of this additional cleanup. I think what you presented very nicely is the added value of the EBMs that can detect estrogens present in a sample, or estrogenic compounds present in a sample that are not our target compounds, E2, EE2, and so on. And I think with each additional cleanup, you have the possible interference that you extract or remove estrogenic samples, estrogenic compounds from the sample that you would detect if you do not perform this cleanup. Do you, in your evaluation study, do you compare EBM testing with and without additional cleanup? So this might be an interesting point just to see if you have losses in activity with or without cleanup. This would be my doubt. Yeah, thank you.
Well, an idea of eventually the loss could be done by the absolute recoveries, because anyway we will have an idea, and in case we will observe a significant loss of recoveries, it might be possible that we will repeat the some analysis without considering the additional step of the cleanup, just to see if this loss is due to the cleanup. But at the moment, we are quite confident in the results, and before planning further analysis, of course, we need to evaluate the data that we have and that we are producing. And when we will see some significant changes or something that it might be due to the cleanup, maybe we can change something, or maybe we can investigate. Unfortunately, as I was saying to you, the validation process on EBMs is ongoing, and I do not have I cannot answer now at this moment, but for sure we have decided to add this cleanup procedure because, for example, MIP is very efficient in removing the DOC, and we have seen that DOC can have an impact on the bioanalytical concentrations. So first, we wanted to test the effect of our procedure in removing all the possible effects due to the matrix in terms of DOC, for example, in terms of the structure of the matrix itself, and of course also in terms of eventually the most frequent interferent components. But if we do not succeed in terms of absolute recoveries, we will plan further experiments.
Thank you.
Thanks to you. Any other further question?
At this moment, we have no comment or question on the chat.
Okay.
So maybe Christian, would you want to talk?
Okay, so thank you, Karine, for handing over to me. Good morning also from my side. So as we have seen during the last 2 days, sample preparation is very essential, not only the pre-concentration, but also the purification of the extracts. In the consortium, we decided to harmonize the sample preparation for the MS-based methods and the effect-based methods, which Monica already mentioned. So in the next few slides, I would like to talk about this strategy. So as Monica already mentioned, to avoid cross-reactivity from whole water matrix components, it is essential to have a specific sample preparation before applying effect-based methods like Calux or the IS-assay. So here we decided to apply a 2-stage pre-concentration and purification protocol, which is suggested by the consortium and is also suitable for MS-based techniques. As already mentioned before, the procedure was also applied in both validation studies, either for the MS-based methods and for the effect-based methods. But the use of isotopically labeled internal standard is not possible, but it's also not necessary for effect-based methods. So the first step in our sample preparation is the pre-concentration. Here we are using the SPE disk, which is a good compromise between the filtration of the sample and the enrichment of the analytes. Here we have several different selectivities with regards to the sorbent materials. Here an example, we can use the HLB SPE disks with a distinct capacity to enrich the analytes and to separate the matrix compounds. And here is the protocol for the HLB SPE disk procedure. So first we have to conditioning the SPE disk with acetonitrile, then with water. Again, then we are able to load the complete whole water sample without internal standard to the SPE disk. It takes around 30 minutes of time. So it's a very speedy procedure in comparison to the normal SPE cartridges. And after loading the water sample, we have a washing step with millicube water. And after that, we are drying the SPE disk by applying a vacuum for 5 minutes. After that, we have the elution step. We are using 5 portions of 10 milliliters of acetonitrile and the organic extract, which is yellowish, can be concentrated with nitrogen to, for example, 1 milliliter. And this residue can be reconstituted in 75 milliliters of millicube water. And this solution can be purified by the molecular imprinted polymer solid phase extraction. Here we have a distinct protocol from the cartridge supplier. And here we take the complete volume of 75 milliliters of water from the previous SPE disk pre-concentration. We have to load the sample with a very, very low flow rate of around 1 milliliter per minute. And after that, we can elute the analytes from the cartridge with 3 milliliters of methanol. And this can be concentrated with nitrogen to dryness, and then we can apply the solvent which is compatible for the EBMs. And to see the efficiency of the pre-concentration and the purification procedure. You have on the left side the picture A, which is the high complex matrix water sample. In picture B, you see the extract from the SPE disc, which is also colored. After that, we evaporate most of the organic solvent. Then we have picture C. We have only 1 milliliter left from the extract. After that, we can dilute the extract from the SPE disc with a distinct amount of water. You see in picture D, and then we can load this water sample on the molecular imprinted solid phase extraction cartridge and do the purification. And after eluting with methanol, you see the extract of the purification step in picture H on the left side. You see a very clear extract. And in comparison to this purification step here, we have in picture H on the right side an extract from a typical HLB SPE pre-concentration, and this is very yellowish. So we also measured the DOC content in both extracts, and in the extract from the pre-concentration with common HLB SPE, we have an DOC content of around 20 to 50% of the initial DOC, and after MIP purification, we have only 1% of the initial DOC content. So the purification step is very efficient with regards to removing the matrix components from the water sample. So are there any questions with regard to this very specific sample preparation and procedure for preparing the EBM samples?
Sebastian?
I think this ME-SPE was introduced yesterday or even on Wednesday, that I'm sure that I remember correctly. These were the ones where you really have, you capture specific molecular structures by this molecular imprinting, right?
Exactly. So okay. You make a kind of organic synthesis of a template from the estrogen. And the mode of action of the molecular imprinted polymer SPE is a key lock principle. That means the estrogen fits exactly in the lock of the synthesized template.
Yeah, thank you. Or perhaps another question. When we do our method, we usually perform a classic SPE with a methanol extraction in the end. You would provide your SPE protocol as well, that we have all the knowledge to do this according to your procedure?
Yes.
Thank you.
So you are using only one pre-concentration and purification step, as I understand. Yeah. Okay.
So that's, I think I told this yesterday or on Wednesday. A colleague of mine, Michael Schlüsener, I think he applied for the ILS as well for the mass spectrometry, and we participated in a project where Europe-wide surface and wastewater samples were collected, and some comparative analysis from MS and effect-based methods were done, and there we did a cleanup with silica matrices, and there we saw a kind of a loss of I think in this case it was the estriol that was lost. But of course it's another kind of a cleanup, and Therefore, at that stage, we set for the EBMs, because we want to capture the overall estrogenicity. We skip kind of cleanup that is, of course, necessary for the MS to reduce iron suppression or something like this. But for the EBMs, it was not a problem, and especially for the method that we apply. That is a kind of a combination with chromatography, and then many compounds just stick on the plate and do not migrate and does not interfere with the detection later on.
But it's also known that, for example, humic substances, especially humic acids, also have an estrogenic activity, and this could make a cross reactivity with regards to the analytes we want to elucidate. And therefore we decided to separate the matrix compounds from the extracts, to be sure that we have only our analytes of choice, our target analytes in the extract, and nothing else. And we want to harmonize both validation studies, that means mass spec based methods and EBM based methods, and so that's the reason why we apply it on both techniques.
Yeah, I understand. Thank you.
We have Elizabeth.
Yes, thank you very much, Dr. Christian. I just wanted to ask, this method for the determination of estrogens in samples, is it a new method? If yes, I would really say I enjoyed the program, because it's nice knowing that estrogens can be detected just like other micropollutants can be detected using the CLUE method. I mean, the conditioning, the SP method involving the conditioning, loading, elution, then washing before detection. Thank you. I'd like to know that.
Thank you very much. So it is a new method, not the single steps. That means the molecular imprinted polymer SPE is not new, and also the SPE disk is not new, but the combination of both procedures was not taken into account.
Okay. So this is relatively new, you mean?
Yes.
All right. Thank you very much.
Okay, if there are no further questions, I think I will go on with the presentations on the IS bioassay. Okay, can you see my screen in full screen?
Yes, Christian.
Okay, perfect. So going on with the IS assay, I want to give you a short introduction to this bioassay. We'll talk about a little bit on the mode of action of this assay, and want to present the way of data evaluation and data processing. So the IS axillary yeast estrogen screen is a method for the detection of estrogenic effects. It is commercially available test provided exclusively by New Diagnostics, which is a German company. And the IS is an effect-based 96-well assay for the detection of estrogenic activity in various types of water samples. The IS uses the non-conventional and recombinant yeast as an estrogen responsive biosensor. It is applicable to ultra-pure drinking and mineral water, surface water, groundwater, and well water, sewage, seawater, and also brackish water, and can be applied for aqueous extracts and for substance testing. So the IS is a robust assay for analyzing the EEQ, that means the 17-beta estradiol equivalent, and the LID, that means the lowest ineffective dilution of samples, especially with high matrix load or with high salt content. In this case, no sterile conditions are required for the whole test procedure. And the IS is a standardized method according to ISO 19040-2 from 2018. And an international interlaboratory trial was performed for the method validation. The reference standard for calibration and quantification is 17-beta estradiol, and the dose response curve responds to the non-linear model. So here we have the mode of action of this bioassay. The AS yeast cells containing a receptor expression cassette with a constitutive TEF1 promoter and the gene for the human estrogen receptor. We have a second expression cassette, which is a reporter expression cassette with a GAA promoter with a recognition sequence for the estrogen receptor equipped with a gene for the enzyme phytase, which is a reporter gene. And this enzyme phytase catalyzes the dephosphorylation reaction to a specific dye. You see here on the right side, the dye is para-nitrophenylphosphate, and the enzyme phytase make the dephosphorylation, and then we have this para-nitrophenolate, which is a color compound and can be detected photometrically at a wavelength at 405 nanometers. And what we need for applying the IS assay, so we need a temperature-controlled orbital shaker. We need a deeper plate reader with the wavelengths of 405 and 630 nanometers. We need a centrifuge with a rotor for deep well plates, and we need some pipettes, for example, a single or a multi-channel pipette. And here we have a typical protocol for doing the IS assay. So first we have to activate the freeze-dried yeast cells by washing and dissolving in a medium. We have to incubate this for 1 hour at 30 degrees and 350 rounds per minute at the orbital shaker. And we have a stock solution of activated yeast cells in 9.5 milliliter medium. For incubating the samples, we have to fill the cavities of the deep well plate with 100 microliter of the sampled solution, calibration samples or calibration levels, and the negative control. And we have to add the yeast solution to each cavity. Then we have to incubate the plates for 20 hours at 30 degrees and 350 rounds per minute at the orbital shaker. After that, we centrifuge the deeper plate at 3,700 rounds per minute at 25 minutes. We pipetting 40 microliters of supernatant of each cavity to a new deeper plate, and we add the mentioned dye solution to each cavity. Then we have to incubate it again for 1 hour at 37 degrees Celsius, And after that, we can read out the colored cavities with a deep plate reader at 405 and 630 nanometers. And here you see a typical pipetting scheme of the 96 well plate. So here you have, for example, the negative control. Here in column 1, you have the calibration samples or the calibration levels. And in between, you have your solutions you want to investigate. That means the samples. And here we have the spiking of the calibration standards ranging from 1 nanogram per liter up to 80 nanograms per liter, for example. And here you have the diluted samples in between. And this is a readout from the deep well plate reader. And with these raw data, we can go to data evaluation, and the data evaluation will be carried out by a web tool with free access provided by New Diagnostics. It's very simple and intuitive to use. We have statistical assessment of the results. We get nice graphs and customized reports for the data. In the next few slides, I show you some examples of the report and the graphics. First, you see the calibration curve in the range of 1 to 80 nanograms per liter, quite nice. And here you have some characteristics of the calibration curve, the typical values you see here. You have also the limit of detection for this calibration curve as quality control parameters. And you see the calibration curve and the data evaluation of the diluted samples. And as I mentioned before, you get also a summary result of the sample analysis summarized in a very nice table. And yes, I think that's was the presentation for the areas, because I have the problem. I'm only applying these tests. I'm not an expert on this special IS assay, but I know that there are some participants in the audience who are very familiar with this IS assay, and I invite them to give some further detailed information or additional comments and hints on this assay. So thank you very much.
Thanks, Christian. I think that at this moment we have no comments or question. Yes, Martin, Jane?
Yeah, hi everyone. Thank you for the presentation of the AS assay. I'm honest, we are the inventor of the AS assay, and I can give sufficient support at any time within this project whenever it is needed. Also, we can contribute material and the assays for free if it's necessary. That's only one thing I want to add within this presentation or within this workshop.
Thank you very much for this comment. It's very nice to hear that we have support from your side. It's very nice to hear.
Yeah, you're welcome.
Good morning, everybody.
So I think I will directly hand over to Carlotta to do the next presentation, I think.
Thank you, Christian. So can you see my screen in full presentation mode?
Yes, it's okay,
Yes.
Carlotta.
Okay. So good morning, I'm Carlotta Scenzi, and I will guide you through the basic steps to perform the ER-alpha Calyx bioassay. The ER-alpha Calyx is used to detect and measure the presence of estrogens in real-world water metrics. The test requires the use of cells that are genetically engineered, and in fact, these cells can produce the enzyme luciferase in response to a defined pathway that is activated. The amount of luciferase produced by the samples is related to the unknown concentration of a reference compound, and the final results are therefore expressed as reference compound equivalents. First, the samples undergo an extraction phase, and then the extracts can be analyzed by Calyx bioassay. The analysis takes 3 days. In the first day, cells are seeded in a microtiter plate. Afterwards, in the second day, the extract dose medium and the reference compound dose medium are prepared, and the cells are exposed to the exposure medium. And in the third day, the response can be measured. In the one, it is important to choose the first day of analysis. For example, you can start on Monday and measure the luciferase activity on Wednesday. Another important thing is to verify that the confluence of the cells is between 85 and 95%. So if the confluence of the cells is between 85 and 95%, the cells can be trypsinate and cultivated in 96 well microtiter plate. From one flask can be prepared 2 or 3 microtiter plates. To cultivate the microtiter plates, the cells are counted with a counting chamber in order to calculate the dilution factor to obtain a cell suspension of 100,000 cells per ml. The cell suspension can be added in the 60 inner wells. And I put a video to show you the seeding of the cells, hoping that it starts. Yes. So in this step, as you can see, the multi-channel pipette can be used. Okay. At the end of seeding, microtiter plates will be structured in the following way. The outer wells are filled with PPS and the inner wells with the cell suspension. Then microtiter plates are incubated for 60-30 hours in the CO2 incubator. For all steps of the day one, it is necessary to work under sterility condition. In day two, the extract dose medium and the reference compound dose medium are prepared. Reference compound and the extracts are both in DMSO, but cells can tolerate a percentage of DMSO between 0.1 and 1%, so a dilution of the solutions are required. For example, an exposure with 0.1 DMSO implying a 1 to 1000 dilution. To obtain this dilution, 1 microliter of extract or reference compound is added to 1 ml of assay medium using a 6 well plate. This is an example of how the exposure medium of reference compound is prepared. First, 1 ml of assay medium is added to each well. Then 1 microliter of reference compound is added to the medium at the appropriate calibration level. Now the cells can be exposed to the prepared exposure medium. Cells are exposed first to the reference compound dose medium, then to the extract dose medium, and each concentration level is analyzed in triplicate. So for first, remove the medium from the top 30 wells, and this is the row where the reference compound dose medium is added. Then add 200 microliter of the lowest concentration of the reference compound dose medium to 3 wells according to the scheme. Continue with the lowest chemical standard concentration until all the standard chemical concentration are transferred to the microtiter plate. In this step, we suggest to use a single channel pipette in order to keep the process under control. With a multi-channel pipette, you cannot guarantee the same accuracy in all wells at the risk of introducing a greater error. For the extract dose medium, the procedure is the same, but the exposure medium is added to the bottom 30 wells. After the exposure, the microtiter plates can be placed in the CO2 incubator for 24 hours. Again, for all steps of the day 2, it is necessary to work under sterility condition. Finally, in day 3, the response can be measured. First, check the cells for signs of cytotoxicity and/or contamination under a microscope. If cytotoxicity is observed in some wells, those wells cannot be considered in the analysis. On the left, you can see a normal monolayer cells, while on the right, an example of a monolayer destroyed by cytotoxicity. Cytotoxicity can occur due to high concentration of toxic substances to the cells, but also for the incorrect or slow exposure execution. To limit the latter cause, we suggest to divide exposure in 2 steps. First, remove the medium and expose the cells of the first row, then do the same for the last rows. In this way, you reduce the risk of drying cells, especially for those of the last wells. After the check, it is possible to proceed with the place reading. The medium is removed from the cells, and then the luciferase can be read by a luminometer. In this step, sterility conditions are not required, and multi-channel pipette can be used. Just a few words about the chemiluminometer, because it is important that the instrument is equipped with 2 injectors. Injector A is placed in the illuminate mix solution containing the substrate necessary to make the luminescence reaction possible. Instead, injector B is placed in 0.25% acetic acid solution used for quenching the luminescence reaction to prevent cross-contamination between wells. This top solution can be different for different chemiluminometers. The plate reading protocol provides that for each well, solution A and then solution B are added accordingly. Dear Alpha Calux, bioessays under license, so if any laboratory were interested, we could provide information on the company selling the license. Thank you. And have you any questions, concerns, or comments?
At this time, we have no question or remarks.
Okay.
Microfono, Monica.
Do you see the screen in full mode, in full presentation mode?
Yes.
And can you hear me well now?
Yes, it's okay.
Okay, good. Here, this my last presentation, I would like to talk with you about the effect-based methods data treatment. The EEQ concentration, which I remind to you that means the estradiol equivalent concentrations, can be affected by the chosen method for data treatment. Reference dose response curves are fitted applied functions that are commonly studied in biological fields, meaning, for example, functions that are sigmoidal in shape. Those response curves for the reference compound may have a different behavior from the ones that are observed with the sample, and therefore the interpolation of the sample can be affected. Sample quantifications is carried out by means of a calibration curve. Here in biological field is also named as standard curve. The standard curve is an approximating function of the true curve, which could be known if we analyzed infinite levels of concentrations, each replicated infinite times. As you can imagine, it is not possible to measure infinite levels each replicated infinite times. Therefore, we are obliged to make a choice. And the choice of the curve model, which we applied to our fitting process, will determine a source of error. One example of S-curve is the 4 parameters logistic function, which is described in the red equation below. I have chosen the logistic function in this presentation, mainly because, first of all, it is one of the most frequent cited function in literature, and moreover because each parameter has a clear definition. In fact, for bottom, we intend the lower limits related to the blank signal. For top, the top is intended to be the upper limit related to the highest effect. For heel slope, we intend the slope of the curve, which gives the idea of the steepness of the curves. And finally, for EC50, we intend the dose corresponding to the 50% of the effect. And from a mathematical point of view, it also corresponds to the inflection point. Generally, these functions, these graphs are reported in logarithmic scale. If we want to improve the quality of our fit, first of all, we should identify the fit of errors. There are, in principle, 2 main contributions. The first contribution is also known as lack of fit of error. It is due to the model function, and it is independent from the number of replicates. We won't reduce the lack of fit of error contribution, increasing the number of replicates. Whereas the second contribution is the pure error, and it is due to the random variation in the data. In this case, it will decrease if we increase the number of replicates. Of course, we need to find a compromise, because if we decrease the pure error contribution, we will increase the number of replicates, but we will increase the cost of the analysis. From a mathematical point of view, there are several approaches. Here, I just want to give you an idea of the most frequent approaches reported in literature. We have the linear model, which determine the bioequivalent concentration by interpolation from the quasi-linear part of the curve. We have the non-linear model, which determine the bioanalytical concentration by interpolation of the whole dose response curve. And finally, but definitely not least for importance, we have the PCX model. In this presentation, I won't give further details of the two previous mentioned models, but I will mainly focus on the PCX model, especially because it's the selected model described at ISO level. The fundamental assumption of this approach is that the dilution series of samples behave like dilution series of the reference compound. This implies the parallelism and same maxima of those response curves among samples and standard curve, the reference compound. Of course, before going into detail of the PCX model, I need to introduce to you the meaning of PCX, its definition, I mean. With PCX, we are referring to the concentration of a reference compound at which a specific level expressed in X percentage is observed. To describe the PCX model, I have also to introduce another parameter, which is the relative enrichment factor, in acronym REF, which gives the enrichment or eventually the dilution of the original water sample, and it is given by, it is obtained by multiplying the concentration factor associated to the sample preparation and the dilution factor that is due to the bioassay application. The first factor, the concentration factor deriving from the sample prep, is given by the ratio between the original volume sample and the final extract volume. Whereas the dilution factor due to the application of the bioassay is given by the ratio between the volume added, the volume of the extract, which is added to the bioassay, and the volume, the final volume of the bioassay. As you can see, both the dilution factor bioassay and the concentration factor sample prep are dimensionless. And since the PC, and this, of course, determine the fact that the relative enrichment factor is a dimensional number as well. Here, I just want to give you a very simple flow which gives you an idea to what to do when you want to apply the PCX model. Once you have analyzed your samples and your calibration solution and you have your raw data, the first thing that you have to do is to carry out the fitting of your calibration curve, of course, choosing your calibration model. Afterwards, what you have to do is to normalize your calibration curve. How do you do the normalization curve? Of your curve? It's quite easy. I mean, I will show you an example of how to do that. But in principle, what you have to do is to set equal to 0% the effect level corresponding to the bottom, and afterwards you have to set equal to 100% the effect level corresponding to the top. Once you have normalized your curve, of course, you decide the effect level to be considered, and you can go through the interpolation, and you can obtain the PCX, for example, at the 10% of the effect value. once you have determined your PCX associated to your reference compound, you can repeat these steps for your sample. So you fit your sample, you normalize your sample curve, and afterwards you can determine the relative enrichment factor corresponding to the same effective level associated to your sample. And the EEQ of the sample is given by the PCX divided by the relative enrichment factor at the same effect level. Here and in the next few slides, I would like to show you a very easy example. In our laboratory, we have implemented the ERA Calux. We are working at 0.1% of dimethyl sulfoxide concentration, and we are working, as Carlotta was mentioning before, with a taken instrument as a chemiluminometer. In that batch of analysis, we have analyzed a reference material, and we have carried out 3 independent measurements of that reference material. Of course, we have analyzed our calibration curve solutions, and we have also considered 2 controls, which are the positive and negative control. Our original sample volume has been 500 milliliters, and our final extract was about 0.1 milliliters, meaning a concentration factor of our sample prep of 5,000. And from from 5,000, we have carried out a serial dilution. Here, this experiment implied the preparation of 2 plates. As good practice and as everywhere suggested, in the first plate, we have to fill the first row with the calibration solutions, which were in this case made up of 8 levels of concentration. In the first column, we have filled the wells with the dimethyl sulfoxide, which is considered as the reference solvent. And at the end, as last column, we add the positive and negative control. In the second part of the plate, we could fill the wells with the first independent replicates. I just want to highlight that we have repeated in triplicate under repeatability conditions each measurement. In the below part of the slide, I just give you an idea of the raw data, and as you can see in the 8th and in the 9th column are missing 2 values, because in that case we have observed cytotoxicity, and we were since we observed cytotoxicity, we did not consider them in the final data evaluation. In the second plate, we have filled the wells with the other 2 independent replicates, again, each in triplicate under repeatability conditions. And in the first column, we have added the solvent control, and in the last column, we have added an additional quality control, which was made up with the repetition, the repetition of filling with 2 different calibration levels. Here, I just go through the data elaboration. So, as I said before, the first step is to fit our calibration curve. In our laboratory, we are actually doing the data evaluation by means of GraphPath Prism. But of course, whichever software that can carry out nonlinear regression can be used. as model, we have decided to follow the most friendly approach, user-friendly approach. Therefore, we have decided to choose and to follow the ordinary least squares and the 4 parameters logistic function. We have fitted our curve. Graph path Prism provides the best fit values in terms of bottom, top, EC50, and also yield slope. And of course, we have also asked to, we have also report the determination coefficient that was quite nice. And in the below part of the slide, you can also see the graph. Afterwards, we have normalized the calibration curve by calculating first the relative induction in terms of percentage. That's why in the red equation you can see the 100 factor, and we have used the values of bottom and top, which have been estimated by the fitting process. Once we have calculated the relative induction, we can ask again the repetition of the fitting to graph pad, and we have normalized our curve. At this stage now, we can repeat the same thing for the sample. So we will normalize the curve associated to our sample using again the values for the top and the bottom, which have been obtained by for our calibration curve. And of course, when everything has been normalized, we have to apply the interpolation. And to apply the interpolation, we need to decide the effect level which will be considered. In our laboratory, we have decided to choose the 10% of effect. So we have interpolated our curve in terms of PC10 and in terms of REF10. And doing so, we have obtained our EEQ values in our sample, dividing the PC10 with the relative enrichment factor. And I want just to highlight that in this case, of course, we obtain in terms of dimensions, because PCX is has the dimensions of a concentration, whereas the relative enrichment factor is an n-dimensional number. Here, the table of our results, so which summarize our results for the analysis of this reference material. The following approach was, of course, the PCX, and the selected level was the 10% of the effect. In terms of repeatability, the results were quite nice, because the relative standard deviation was less than 15%, and also the absolute recovery was quite nice, because we have achieved less than 120%. During this presentation, I have mentioned several quality control checks. This is because within a bioassay batch, responses may change due to either non-specific reasons or to decreasing luciferase levels due to the increasing passages of the cells. Thus, as a good practice, several quality controls should be used. On the left-hand side, I just give you a list of the main control checks that can be applied within ABM's analysis. We have, of course, relative standard deviation of replicates wells. We have the ratio of the reference standard solvent controlled, the one that corresponded to plate 1, and solvents on the other plates. And moreover, we have the ratio of the calibration level, which approximates the EC50, and the calibration level, which provides the highest effect in our calibration curve. On the right-hand side, I just give you the values that are accepted and that are applied for Calux bioassay. So, for example, it's good when we achieve repeatability between 15 and 30%, depending on the concentration. Other quality control checks are related to the fitting, to the quality of the fitting, implying also the determination of the EC-50 range, and also the determination of the positive control relative induction or the negative control relative induction. And again, I just give you an idea of the values that are in use for Calux bioassay. So it's good when the determination coefficient of our calibration curve is higher than 0.98. And we should obtain a relative induction for the positive control less than 30% or no, higher than 30%, and for the negative control instead should be less than 10%. The observed EC-50 value instead is also depending on the dimethyl sulfoxide concentration. And that's it. I don't know if you have any questions or comments and concerns also related to this part.
We have Sebastian.
Thank you very much for this presentation of this demanding issue, I think. You mentioned that, of course, the choice of the fit model is important for the data evaluation. For the interlaboratory trial, you say, let's, for example, fitting according to 4-parametric regression is then mandatory, or is it free for the participants? Or do you say, okay, we collect the raw data and do the data evaluation on separately? What is the plan there?
It has not been decided yet. Maybe I will come later. What I can tell you for sure that we won't do the data evaluation of your raw data, but I think again, it's just my idea. It's not a decision. We will come back later to you, but I think that what we will ask is just a clear statement of the model that you have followed, that you will follow. Because, for example, we will now, within the method validation, we are applying the 4-parameters logistic function. But I know that that at ISO levels, they are recommending the 5-parameters logistic function. But I don't know how many laboratories have implemented this kind of model. Because the most frequent one is the 4-parameters function. Which model do you normally apply for your data evaluation?
We use the YES assay, not the IS, so it's the ISO 19040. So we usually use a 5-parametric because it gives much better fits. I think for the and it depends a little bit on the way you calculate the biological equivalence level. When you showed these different approaches, and when I think now the PCX method, because it's an ISO standard, should be used, and in this case the lower part of the curve is very important to be exactly modeled, and the higher part of the curve is not that relevant, I would say, and therefore perhaps the 4 or the 5-parametric models would not make that much of a difference. What we observe very often that there's a kind of an asymmetry in the curve, and that it starts sharper but then has a slower approach to the upper asymptote. And this can be captured by the 5-parametric model better. And that was the reason why we use the 5-parametric. But I totally agree with you. A nice thing for the 4-parametric is that you have a clear understanding what the parameters reflect in reality. And this asymmetry, I have no real idea what is this really reflecting on the biological level. But yeah, it's a kind of a decision. You want to capture your data most accurately, or have a kind of a more mechanistic model describing your data.
Because sometimes we put too much effort and then things are not changing that much. I mean, so making the model too complicated maybe won't help in the data evaluation. It will provide maybe the same results, and this can be also an added value of the project, because what we wanted also to see the differences among applying different models. But I know that at ISO level they are recommending the 5 parameters logistic function, but with this levels of concentration, since we do not have so high contaminated samples, it might be that we won't see any differences in applying the 2 different models.
Yeah, this might well be. Yeah. And perhaps just allow me one comment. At the moment, there is a SEN voting about the ISO 23196. So
we will talk of it just after. We will have a specific talk on that just after.
Okay.
So and please feel free to jump into the discussion when we discuss on that. But it's in the plan just after.
Okay. Thank you.
Perfect. It's so nice to have you with us. Really, thank you very much for all your feedback and exchange with us. But we will just have a few discussion on standardization issue just after.
Okay.
So thank you very much.
Thank you.
Thank you. Do you have any other question or comments, Sebastian?
No, at the moment. So yeah, there are many things in detail, of course. So the ISO has another approach to assess the quality of the fit. So what you showed,
the chi-square, yes, chi-squares, yes.
Yeah. And so I'm not that much a statistical expert, but someone said that the R-square, I forgot the reason, is tends to be, let's say, a little bit over optimistic what the quality of the regression is. And therefore we said for the ISO, for the BQ ISO, okay, we looked for another approach assessing the quality of the fit. And we just participated in the standardization for the DR Calux that is running at the moment. So at least the data that we produced in our laboratory, when I applied this approach now, the 4-parametric fitting of our data would fit the R-square test, but would not fit the chi test. So, but the 5-parametric would fit, would pass the chi-square test.
It's the same for us, because what I have noticed, for example, but again, I'm a chemist, I'm not a statistician, but so I cannot fully understand the differences, but chi-square is a more strict parameter to check the quality of the fit. And what I have realized that, for example, even determination coefficients of 0.998, which is quite good, provides a not sufficient chi-square, as you were saying. And I think that maybe that increasing the number of calibration levels could help, because for in the ISO they recommend to so if we have a 4-parameter logistic function, we should analyze at least 4+2 levels. And what I have noticed that, of course, if I'm applying a 4 parameters logistic function. If I have, for example, +3 levels, it might be that I fit in my value of key is good for the fitting, but I have noticed the same issue, that it's not that easy to fulfill the key square that is recommended in the ISO.
Yeah, and perhaps you are right that in the end, because with the PCX you need the lower part that has to be accurate, and yeah, perhaps it's too much effort for the same outcome in the end.
Yes, exactly. It's too much. Maybe it's too much effort, and I mean, but the good thing is that once you have the results, you can always reevaluate the results, changing the model, because we have simply to ask GraphPath to repeat the data evaluation, and we can see if the fitting is increasing its quality.
Yeah.
Are there other questions? If not, so we are early in the agenda because we have squeezed the first presentation because it was unnecessary. So I propose perhaps that we do not make the coffee break and we go on the agenda. Doing so, we will finish earlier, and you will, I'm sure, will be free to go to your busy agenda. So I would, if you agree, propose to go on the agenda. So as it has been previously said by Monica, our initial plan was, of course, to show you the results of the validation of the EBM we are undertaking on the project. But COVID is COVID, and we have been obliged to delay some tests because of COVID wave during the summer. So we are not in capability to show you the full data set and the validation results of the EBM, as we have decided to implement in the project. So we had two options: postpone the meeting or assume to bring all the full result, and chosen the second option. But we will be pleased to share this result with you, especially at the occasion of the meeting we plan to organize to discuss on the result on the inter-laboratory comparison with those of you who will participate. And we will seize this opportunity to share with you the result of our validation data. And of course, we will keep you informed about the end of the project, and you will find everything in our website. So we apologize not being able to show you and demonstrate you the potencies of EBM as an alternative detector. I prefer to precise it like that, as an alternative detector to MS-based method. It is really the strategy we have chosen to implement in the project, and this is why we have implemented this chosen to implement this sample prep approach. We know that we are becoming very specific, but it was to really evaluate the potencies of EBM as an alternative detector with respect to mass spec. So now I will present you some next steps as we have made for the MS-based method. So coming back to, I don't know if you see my screen.
Not at this time, Sophie.
So I have to share it with you. Is it okay now?
Yes, perfect.
So next step, so let's go to talk about the inter-laboratory comparison we are organizing. And I'm sure there will be many questions with respect to EBM, is this inter-laboratory comparison? And we will have also some information on standardization. So to remind, the aim of our ELC is to demonstrate the fitness for purpose of the optimized and validated method in the project, both MS-based method and effect-based method. The ELC will allow to define performance characteristics of the method in terms of repeatability within laboratories and reproducibility of the validated method, and support some standardization process, and especially for EBM, revision of existing standards or some complement or annex to be added to these existing standards. So just a reminder, we have yet discussed on that yesterday. So we will provide you protocols by the end of September. The material will be delivered beginning of November, and you will have 3 weeks to perform the test and provide the results to the organizing committee. Then by 20th of December, we will provide you a first evaluation of the statistical evaluation of the data set. And then we will come back by mid-February with a final report. And we will plan, as I told you before, a meeting to present and discuss the results. And it could be a good opportunity to have a broader view of all the EBM achievements, notably those who cannot deliver to you today. So once again, two materials representative of natural waters will be delivered, and one QC as a blank water. It will be delivered as kits to be reconstituted by each lab, and each kit will be based on water, SPM, DOC solution, and spike solution, and you will have a written protocol in order to allow you the implementation of the protocol to make the kit, and we will also have a support with video to show you how we implemented in the lab to help you in the design of this on your own material. Of course, we really need you. As I told you yesterday, it is really a trial to have this all our communities to improve on estrogens measurements, either by MS-based method, either by BM method, to be on time and on good way to support the implementation and the revision of the Water Framework Directive. So you have here the links where you can register, and you will have all the information necessary to understand how we will proceed. And here I remind that we have our key contact person in charge of the organization of this interlaboratory comparison for the project, Paolo De Zorzi, Timu Naiki, and Sabrina Barbizi. So if you have some question, of course, we can start to discuss on some of them today, but do not hesitate to contact them, and we will provide you feedback as soon as possible. Other point, very important, as we have shown you at the beginning of this 3-day session, our project is really supposed to deliver input to the regulation. So if for EBM, we have yet some existing standards that are ISO standards. And as it has been introduced a few minutes before by our colleagues, there has been a ballot process at the European level. The ballot is organized, of course, by the SEN standardization body to evaluate the potencies for these ISO standards to become SEN standards. And now the ballot is closed, and I can tell you that this standard has been accepted and they will become SEN standards. At the level of the project, we have provided a paper that is based on feedback and input, because as it has been presented by Monica and Christian and Carlota, we have also considered these existing standards to be implemented in the project. And when we have evaluate and read this standard, we have seen some specific point and possibly error and or improvements of this standard. So we have made a paper summarizing the position of our project to support this ballot process and especially to support the next year revision of these ISO standards. So it was just to make a point that we are also supporting the revision process of this ISO standard, really to improve them, to reliable the measurements that we deliver as necessary to support the implementation of the WFD in Europe. And with that, it was my last slide. And if you have comments and want to jump into the discussion, please feel free, either for the standardization, either for the interlaboratory comparison. Do you have questions, comments?
Elizabeth, who you want to talk about your question, please?
Oh, please, what time will this training come to an end? In a few minutes, we will close quickly. Did I answer your question?
Yes, very well. Thank you.
You're welcome. So Sebastian, I do not know if you want to jump into the discussion with respect to the standardization process and so on.
Yeah, I'm really sorry. At the moment, two things are running in parallel. So perhaps you know the Park initiative.
Yes, of course.
Yeah, and right now on another channel is a discussion about effect-based methods and analytical methods for endocrine disruptors. So that's an unfortunate collision of the two things, and I try to follow both a little bit. For the standardization, I think it's really great that the activity builds on the ISO 19040 series and adds the things that are missing in there. What you addressed to really make it usable for the Water Framework Directive. So I think this is a really great thing, because when we worked on this series, we had the same discussion. Do we want to standardize only the bioassay, or do we include the extraction and all this? Yeah, and at that time we decided to focus on the bioassay, because we said, okay, that's enough trouble, and we put the extraction for later. And then another aspect was that we wanted to have a standard for the whole water assessment without extraction, and the extraction is only added in an informative annex.
Yes.
And but now when we discuss EBMs for regulatory purposes, I get always the question, what about enrichment? And so this is great, really, that you tackle this in your project. And it, when this would be possible to add it in a later amendment of this standard, that's great.
Yes,
I thank you very much for your activity.
Thank you for your positive feedback, because it was really the objective of the project, to really support all standardization process that are needed to also support regulation, especially European regulation. So it's clear that we are involved in many of us in the project are also involved in standardization at national level and are part of international activity. So really we will push everything, but we have also to consider that there are ISO standards and we are talking about European problematic. So perhaps there will be some difficulties at the ISO standards. So perhaps we will need to have some specific items or implementation, I would say, managed by the SEN, because we have specific problem in Europe. We are the most, I would say, demanding. We have the most demanding regulation, and in other countries, perhaps people will be against such kind of evaluation. So we will have to deal with that. Yes, so yes, all the things that will be learned by the project will be pushed to the standardization at international level. First, because to avoid any duplication of work, because if we have made something which is relevant, it's nice that everybody knows, and to avoid duplication, and really because we think it is a way to really support the recognition of EBM within Europe, and especially for regulatory purposes, because it's still not totally agreed as something robust as could be MS or classical approaches, and also because we need to really inform policy makers about their potencies, their limitation, what is still needed, and yes, it is really the plan of the project.
Thank you very much again.
Thank you for your positive feedback, really, thank you. And I think, of course, Park will also deliver very nice things in the coming years. And perhaps some things that the metrology community will be able to take in hand and to pursue. It would be nice to make it like that also. So thank you. Are there other questions with respect to the interlaboratory comparison, as instance, or with respect to other issues linked to EBM or other issues that are addressed by the project? So if not,
Sophie,
yes,
one question about Elizabeth.
Yes, please.
Elizabeth, you raised your hand?
Yes, I did. I just wanted to say that first of all, I want to say thank you to the organizers of the program. And I want to say that I can't wait to explore all the things I've learned in this training so far, because although I have analyzed the estrogenic activities of pharmaceuticals, but using just the YES assay and not this particular method. So I hope to use this method in the nearest future. Thank you.
Thank you. Are there the raised hand, Karine, or comments?
No, I don't see anything.
Okay, so I think now it's time to close these surveys and to also close this training. On behalf of all the partners of the project, I would like really to thank you for attending this meeting, for your positive feedback and the nice discussion we had during these last days. So if you want to follow us, if you have our website and you have the QR code, and you can go directly to the website. And of course, we will keep you informed about the next step of the project. So of course, the interlaboratory comparison, of course, the results of our project, the global results, the final results of the project, and all the activity we plan to organize by the end of the project, and especially a meeting to share the final last result of our project. So really thank you all of us for attending this meeting, and it's now time to close. And once again, all my thanks, and on behalf of my partners. Thank you.
Thank you, Sophie. Thank you to everybody.
Thank you.
Thank you.
Thank you. Bye.
Thank you.
Bye-bye.
And
Bye.
we will share everything soon.
All right.
Thank you. Bye-bye.
On se retrouve maintenant pour le débrief?
Yes, just 5 minutes pause.
Yes, and for all the partners, we go to the debrief station just in 5 minutes. Is it okay for everybody?
Yes.
Yes. Have you already sent the link?
Yes.
Okay, thanks.
See you.
See you.
Je vais descendre.